Welcome to a video where we will identify the values of the variables and solve with the TVM solver. In this video, we're going to focus on an annuity problem where we're asked to find the payment. Let's get started. The TVM solver, or the time value money solver, is an application that allows you to quickly solve compound interest problems, including annuities and loans, without using the formulas. I've included a link to the free time value money solver in the video description below. I've also included a link to an introductory video on the TVM solver. So if this is your first video learning how to use the TVM solver, you might want to look at the introduction video first. Before we get started, a few important tips about the TVM solver. For the variables that represent cash, you need to pay attention to the direction of the cash flow. Cash outflow, or money that is being paid out, are considered negative. Cash inflow, monies that are coming in, are considered a positive value. Deposits and loan payments are negative because they represent an amount you must pay out every month. Let's take a look at our problem statement. Noah wants to have $42,000 in an account after 6 years. How much should his monthly deposit be into the account if the account pays 4.6% interest compounded monthly? On the right-hand side of the screen, you should see a list of variables that are used in the TVM solver. Let's go through each variable and identify its value in the problem. The first variable that we need to find is lowercase n. This is the number of times interest is compounded in 1 year. So toward the bottom of the problem, we see that interest in this account is compounded monthly. That means interest is compounded 12 times in a year, so lowercase n is 12. Now let's find t, the amount of time the money is going to be in this account. It says Noah wants to have $42,000 in an account after 6 years. So the money will be invested in this account for 6 years, implies T is 6. Now we can calculate capital N, which is the total number of payments or compounding periods. This is when we take lowercase n and multiply it by T. N is going to be 12 times 6, which is 72. Now let's find I, which is the annual interest rate, but we need to enter the interest rate as a percent and not a decimal. It says that this account pays 4.6% interest, so I is going to be 4.6. Now let's find PV, which is the present value. This is the principal or starting amount in the account. This present value can be a little tricky. It does not explicitly state that Noah is going to start with an initial investment of $2,000, $3,000, $4,000. So in this case, we need to assume that he is going to start with an initial amount of 0. So the PV, or the present value, is going to be 0. It only says he's going to make monthly deposits. It does not reference a starting or initial amount. Now let's find PMT, the payment amount. These are equal and regular payments. The problem says how much should his monthly deposit be in the account. So PMT is actually what we're looking for. We're looking for how much he needs to deposit. So PMT is our unknown value. The future value is the accumulated or ending amount. Toward the beginning of the problem, it says Noah wants to have $42,000 in the account. So our future value is $42,000. But because this is a cash value, we have to think about the cash flow. Since this is money that will eventually be paid to Noah, this is a cash inflow. So future value should be positive 42,000. Now, PY and CY are the number of payment periods and compounding periods per year. These should always be the same number. And if you look, it says that he's going to make monthly deposits and interest is also going to be compounded monthly. So both PY and CY are going to be 12. Now let's go over to our TVM solver, input these values, and then find the monthly payment. Here is the time value of money solver that I have included as a link in the video description. We found that capital N, the number of compounding periods, was 72. I, the interest rate, was 4.6%. PV, the present value, was 0. He's not making an initial deposit into this account. PMT, the payment, is the unknown value, so we'll just skip that for right now. FV, the future value, is positive 42,000, since that value will eventually be an inflow for Noah. And PY and CY are both 12, since there are 12 payments Noah will make each year and 12 compounding periods each year. Now, since we're looking for the payment, let's go back up to the line where it says PMT and press solve. And we see that we get a negative value, negative 507.64 cents. The negative just represents the cash flow. That is a cash flow out of Noah's pocket into his account. So Noah will need to make deposits of $507.64 each month. That's it for this video. Thanks for watching.